Hello, my dear students and the rest of the learners. Welcome to part 14 of a 41-part series of tutorials in Fundamentals of Object-Oriented Programming in Java. In this tutorial, we are going to look at the relational and logical operators as used in Java. My name is MemJM, or you can simply call me Emily Swap. What are comparison or relational operators? Comparison operators are the operators that are used to compare two values or variables. This is important in programming because it helps us to find answers and make decisions. The return value of a comparison is either true or false, and these values are known as Boolean values. So the following is a table indicating various operators, including their order of precedence, their names and examples, and the kind of value they return. Number one is less than operator. For example, x less than y. e.g., is 4 less than 5? That is true, so it returns true. Greater than, which means us is x greater than y. For example, is 4 greater than 5? The answer is no, so it returns false. Less than or equal to, is x less than or equals to y? For example, is 4 less than or equals to 5? That is true, so it returns true. Greater than or equal to, is x greater than or equals to y? That is 4 greater than or equals to 5? The truth of the matter is no, so it returns false. Then we have equal to, is x, the content of x, equals to the content of y? For example, is 4 equals to 5? That is not true, so it returns false. Then we have not equal to, not equal to. Is x not equal to y? In other words, is 4 not equal to 5? That one will return true. It's not equal to. The other category of operators are the logical operators. The logical operators are used to determine the logic between variables or values. Examples include the logic OR. And my dear students and the rest of the learners, kindly pay attention to how we write them. The OR, we call it the logical OR. It returns true if one of the statements is true. For example, is x less than 5 or x less than 10? That is true. Then we have logical AND. Logical AND. It returns true if both statements are true. For example, is x less than 5 and x less than 10? The answer is false. That's not true. We have exclusive OR, and kindly pay attention to the way the symbol looks like. Exclusive OR. It returns true only when one of the statements is true, while the other is false. For example, is x less than 5 and x less than 10? That is true. Then we have the logical NOT. It reverses the result, returns false if the result is true. For example, not x less than 5 and x less than 10, the answer is true, or it will turn true. So what is the precedence of operators in Java? Generally, regardless of the type, all the operators in Java have certain precedence. So Java operators are evaluated according to the precedence hierarchy shown below. The lower the precedence number, the earlier an operator is evaluated. The lower the precedence number, the earlier an operator is evaluated. So the operators at the top of this table are evaluated before operators that occur below them in the table. The operators at the same precedence level are evaluated according to their occasion, either left or that is according to their association, either left to right or right to left. So the following are the operators and the under precedence or associativity. The very first one is parenthesis. That has the highest precedence. Then we have post-increment, post-decrement, and what we call the dot operator. All three are at the same level. So the order of precedence is equal. So in this case, you evaluate them or they are computed from left to right. We have the pre-increment and pre-decrement. The unary plus, unary minus, Boolean not. All those, they evaluate or they executed from right to left. Then we have type, new. So this is typecast or object instantiation. It's used to typecast or indicate what we call the object instantiation. Now, they are evaluated from right to left. We also have three other operators that are the same level: multiplication, division, and modulus. So these ones are evaluated from left to right. Next is addition, subtraction, and string concatenation. They evaluated from left to right. Others are the same order of precedence are the tags. That is, the less than, greater than, less than or equal to, greater than or equal to operators. These are called relational operators. They evaluated from left to right. Next one is equality operators. The equal to and not equal to. These ones are evaluated from left to right. We also have Boolean exclusive OR. It's evaluated from left to right. We have AND, which is Boolean AND. It's evaluated from left to right. Then we have Boolean OR, evaluated left to right. And then we have other assignment operators, all of them at the same level. The assignment operator, addition assignment operator, subtraction assignment operator, multiplication assignment operator, the division assignment operator, and the modulus assignment operator, all of them are evaluated from left or from right to left. So the following is a sample program implementing relational and logical operators. So we have the name of our package being logical relational operators. Then import java.atil.scanner, which tells the compiler to use a scanner class from the package java.atil. We move to public class, logical relational operators. As you can see, my dear students, the rest of the learners, the name of the package and the name of the class are similar. Then we have the public static void main, which is the method that controls the rest of the program. And then we create a scanner object to enable us to manipulate the inputs and the outputs. So the name of the scanner, or the name of our new object is scanner. So the statement is new scanner system.in. Whatever you generate, assign it into scanner. So this statement is simply creating an object, a new object. Then the next statement is declaration of variables. Next, we declare a variable called taxpayer and we initialize it to 0, 0. The pay rate, we assign it to 500. The tax rate, we specify it is 0.10. Overwork rate, 1000. In other words, overwork rate is being initialized 1,000. Then tax relief is being declared and initialized at 500. Next is declaration of the variables hours worked and hours overworked. Then you prompt the user, how many hours have you worked this week? The user keys in some value, and the value is read as integer, and it is assigned the memory location called hours worked. From basic pay, you pick what is in the basic pay, that is in pay rate, memory location, multiply to what is in hours worked memory location, and assign the results in the basic pay variable. Next is to display the statement, basic pay for regular hours worked this week is, you pick the content of memory location on basic pay and to display it on the screen. Next is to display the statement on the screen. How many hours have you overworked this week? And the user will key in a value which will be read as a whole number and it will be stored in hours overworked memory. Next, the compiler will pick what is in overwork rate memory, multiplied by what is in hours overworked, and the results are assigned in what we are calling the overwork pay memory location or a variable. From there, you can display the statement. The amount paid for overworked hours this week is, you pick the value in the memory location called overwork pay and you display it out at that point. The next statement is a compound addition or assignment operator. Compound addition assignment operator, which is basic pay plus or equals to overwork pay, which can be read as basic pay equals to basic pay plus overwork pay. And then you display the statement. Your accumulated basic pay is, the compiler picks what is in the memory location called basic pay and display it out at that point. Then you have the next expression, which is computation of tax pay, which you compute or get as picking what is the memory location called basic pay, you multiply by what is the memory location called tax rate, and the result is stored in the memory location called tax pay. So we have the if statement like that, which is if the value in basic pay is less than or equals to 2,500 or tax pay or the content of tax pay. I repeat this statement so that you can understand well, my dear students. This statement here reads as, if what is in basic pay is less than or equals to 2,500 or what is in tax pay is less than or equals to what is in tax relief, then do the following. Initialize tax relief to 0, tax pay to 0.00, and then proceed and display the statement. Expected tax to pay is, pick what is the memory location they call tax pay, displayed the screen or on the screen. And then from there, you end the if. Then we have the else section. The else section reads, on the first statement is to display the statement actual tax to be paid is. So that statement will be displayed on the screen, and then the compiler will also pick whatever is in the memory location called tax pay and display it at that point. Then to compute the compound subtraction assignment operator, compute the tax pay, you write tax pay is equals to, or tax pay minus equals to tax relief, which is read in other ones as tax pay is equals to tax pay minus tax relief. The next statement is to display the message tax paid after being granted a relief of 500 is, the compiler will pick whatever that is in memory location called tax pay and display it on the screen at that point. Then we have the net pay. Net pay, for you to get to know the net pay, it is the basic pay subtracted to the tax pay. From there, you display the statement. Your overall net pay this week is, you pick the value in the net pay memo location and you display it on the screen at that point. And then, or with that, we have come to the end of that program. So let's see how it will behave in C. Not in C, but in Java. Let's see how this program will behave in Java. We are going to type it exactly as we have done. So this program can be coded as follows in Java. So we are going to load our Java program, that is our IDE. We are going to load our IDE, which is Eclipse. So we look for Eclipse, here it is. We click on Eclipse IDE for Java developers. And if you are using other IDEs like NetBeans, you can load them. So the IDE that you make use depends with the IDE that has been installed in your machine. So once you are here, you can close all other editors. You can even close the projects. But we have no problem. The projects can remain. So we click on File, New, Java Project. We can call ours, we can give our project a name, and the name can reflect our operators that we are making use of. And what is the name of operators? Which operators are we making use of? So we can call this logical relational operators. Logical relational operators. And then you click on finish. From there, you can right click on your project and then point on new and click class. You can see the name of the package has been already proposed. So let's just type the name for our class, which should be the same as the name of the package. So it is logical relational operators. Logical relational operators. Then we can tick public static void main and we click finish. So here we are. You can see the name of our package is logical relational operators. The name of the class is logical relational operators. So we can add the statement for allowing us to key in values, which is import java dot atil dot scanner. From there, of course, we can indent our code to look attractive, and of course, to make our work easy to identify errors and debug. Then you can remove also that part of code. And then if you have typed your program somewhere else, like using an editor, just right click there and click on paste. So this is our program. This is our program. This is our program. It's making use of various operators. So once you are done with the coding, your program, you can save it by clicking on Save button. But if you want to save it with a different name, you click on File, and then you click Save As, and then you find out where you want to save it. And then, of course, you click OK. So for my case, I'll cancel that. I don't need to save it as with a different name or in a different location. So that's our program. So the next thing is to run it. You click on Run, then Run the menu. And as you can see, my dear students and the rest of the learners, you can see that our program has executed and it has been converted because there is no error. So you can see in the output section, the program is running. It is asking, how many hours have you worked this week? How many hours have you worked this week? So what you do, you just type the hours worked, for example, 12. Then you can see it is asking. Basic pay, or it is saying basic pay for regular hours worked this week is 6,000. 6,000. Then, how many hours have you overworked this week? So you press enter and type the number of hours overworked this week, for example, 7. And then you press enter. Once you press enter, the program will do the rest. You can see it is telling us basic pay for regular hours worked this week is 6,000. How many hours have you overworked this week? We have entered 7. The program tells you amount paid for overworked hours this week is 7,000. Your accumulated basic pay is 13,000. The actual tax to be paid is 1,300. Tax paid after being granted a relief of 500 is 800. Your overall net pay this week is that much. So those are simply the output statements that we have in our program. And then, as usual, once you are done, you can always click on File, then close all editors. And with that, my dear students and the rest of the learners, you can also click on Exit to come out of Java environment or to come out of the IDE environment, and then you are taken back your desktop. So we have seen how our program has worked. And with that, then, we come to the end of part 14 of this series. You can now proceed to part 15 of the 41 part series of tutorials, in which we are going to learn on what we call the sequential control structures, or we are going to introduce control structures, and then we are going to delve into learning about the sequential control structures. Congratulations, therefore, for learning part 14 of 41 on relational and logical operators in fundamentals of object-oriented programming using Java. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 15 of this series, and God bless.